So we learned on the previous page about the product rule, and you can imagine what comes after product. Quotient, yes indeed. All right, so let's do the same trial that we did on the last one. Let's try algebraic simplification first. So we will use the fact that we know that p of x, which is equal to x cubed plus 2x plus 1 all over x squared, is equal to x cubed over x squared plus 2x over x squared plus 1 over x squared. That would be equal to x plus 2 over x plus 1 over x squared. And now I'm just thinking ahead. I want to be able to take the derivative of this. And we know that fractions, well, we don't really have a rule for fractions, so the easiest thing to do is to rewrite them as powers. So this is 2x to the negative 1, right? X to the negative 1 will get you 1 over x, and then multiply by 2. And then plus, and then this would be x to the negative 2. Powers are your friends, right? The power rule is the easiest rule we have, right? So we want to be able to use it, so I will make a note, right? We like to use the power rule. Change to use the power rule. Sorry, my word use got really small in there. Okay, so into these two right here. And that's a little trick for in general. In general, we use the power rule whenever possible, even when after we've learned the quotient rule. The power rule is still nicer for simple ones like this. Okay, so that's that function. So then the derivative, which would be dp over dx, or p prime of x, whichever way you want to write it, would be the derivative of x, which is 1, right? That's rule number 2, actually. The derivative of x is 1. And then now we bring the minus 1 down. Minus 1 times 2 is minus 2, x to the, and then we take negative 1 and we subtract 1 more from the power. It's negative 2. And then we bring minus 2 down, minus 2, x to the negative 2 take away 1 would be negative 3. Actually, let me write that out a little bit more, just one second. There. I don't often do this, but I'll write the intermediate steps since it's the first time we've seen in a while with negatives. So you bring negative 1 down. Negative 1 times 2 makes negative 2. X to the negative 1 take away 1, and then bring the negative 2 down. Negative 2 right here. X to the negative 2 take away 1. So that gets you 1 take away, because plus a negative is minus. So take away 2x to the negative 2. Take away 2x to the negative 3, and in general we would rewrite that as, here I'll write it over here, 1 take away 2 over x squared minus 2 over x cubed. Now this is perfectly correct and lovely and fine. Now, if you want to algebraically put it all together, you don't have to at all, but let me just mention, if I multiplied this term by x over x, this term by x cubed over x cubed, think of what you would have. You'd have x cubed, take away 2x, take away 2, all over x cubed. In other words, I'm getting a common denominator. It was not asked for, it was just a, if you have to do it, there's how to do it. Right? But this answer over here is perfectly acceptable. So all I did was I multiplied this term by x cubed over x cubed, this term by x over x, and that would make this one. All right. Well, that leads us to, we don't want to have to do this all the time, right? Just like we didn't want to have to use algebra all the time to simplify our products, we definitely don't want to use algebra all the time to simplify our quotients. So we need a rule. And the way the rule works is if you take the derivative with respect to x of one function f divided by another function g, notice g of x can never be 0 because that's still a big no-no. You can never divide by 0. All right, if this is the case, then you take your function g, and it goes right here, g times f prime minus f times g prime all over g squared. Also, if you look at it on your derivative sheet, this is actually the way I prefer it. U over v would be v u prime minus uv prime over v squared. Right? V being your denominator function, u being your numerator function. So whichever way you want to memorize it, it should work either way. The order on this particular one matters in a way that it didn't matter for the product rule. For the product rule, it's just derivative of one, leave the other alone, plus, and then reverse the process. But for here, it has to be v in the front. The way I always remembered it was I put v here and v here. So v squared. And if I remember that that v is in front, then I have to alternate it with u prime, and then subtract, and then uv prime. So it's just how I remembered it when I was first learning it in calculus. All right, so that means that we could do that same problem up above in a different way, and it should work out. So let's try it. So without using the algebra simplification, let's look at that function. P of x was equal to, let me write it down, it was equal to x cubed plus 2x plus 1 over x squared. So what I'm saying is we'll call this function up here f, and we'll call this one down here g, or you could call them u and v, whatever makes you happy. All right, so we've got u and g, or u and v, or f and g, whichever way you want to think of it. I'm going to get rid of that division bar. I don't like it there, sorry. All right, so according to our rule, p prime, let's write it down, p prime of x should be equal to, all right, it's going to get ugly for a second. The bottom function, g, gets put right here, g, and you square it, right? So g of x was already squared, so now I need to, or excuse me, x squared was already g of x, and then I square it. So there's g of x squared, and then I put g of x right here, right? So there's g. G is going in here. Oh, actually, let me do it this way. It'll be easier if I color code it. There. There's x squared right here. There's x squared right here. Right? So g of x goes in the denominator and squared and goes up here in the front. And then I multiply it by f prime. Well, f prime is the derivative of this numerator, so that would be 3x squared plus 2. Close parentheses, because the derivative of 1 is 0, minus. Now I reverse the process. So now I leave f alone. So I write x cubed plus 2x plus 1. There's f. Right, there's f prime. And then I multiply it by, oh, I knocked my whole thing. Sorry about that. I apologize. I hit it with my hand. Then I multiply the whole thing by g prime, but g prime would be 2x. Right here. All right, so this is g prime, this is g, this is g. Right, so g f prime minus f g prime over g squared. Well, if you're asked to be unsimplified, you're actually done right here, right? If they want an unsimplified version, there you have it. So watch out for the instructions. If they want it not simplified, you're finished, which a lot of the times we will do, especially on quizzes and those kind of things. But let's simplify it. Let's do a little bit of algebra and see how this works. So if I distribute this, this would be 3x to the fourth plus 2x squared, take away, and then I would distribute the, sorry, my square got a little weird there. So then, let's think, minus, and this is going to take a little bit of doing. So 2x to the fourth, let's see, plus 4x squared plus 2x, all over x to the fourth, because x squared squared would be x to the fourth. So that'd be 3x to the fourth, take away 2x to the fourth, which is x to the fourth. Then let's see here. Two x squared, take away a 4x squared, which would be negative 2x squared. And then, let's see here, no constant terms here, a minus 2x. So I'm distributing the minus as I go. 3x to the fourth, take away 2x to the fourth, 2x squared, take away 4x squared, and then nothing, 0, take away 2x, all over x to the fourth. Now you'll notice, what do these three terms all have in common? Well, they all have an x in common. So you could factor an x out. It leaves you x cubed minus 2x minus 2. This should start looking very familiar to you, because that x right there will cancel one of those out, and it will leave you, we'll divide one of them out, leave you x cubed minus 2x minus 2 over x cubed. Huh. That is the same as that. They're identical, right? So which method do you use? Well, the answer is whichever one's easier. It depends, right? So if for simple ones, for simple problems like, let's see, 2 over x or 1 over x squared, stuff like that, use the power rule, right? You change the rule into a power, right? If it's more complicated, then usually we use the quotient rule and just leave it unsimplified, unless we have to simplify it. Quotient, there we go. So the quotient rule is not our favorite rule, so we try to get out of it if at all possible. So we use the power rule whenever we can. Power rule for simple problems like these. We would change them into 2x to the negative 1, 1x to the negative 2, that kind of thing, and use the power rule. If it's more complicated, then usually we use the quotient rule and just leave it unless we have to simplify it, in which case then we will. But most of the time we don't do the simplification first unless for some reason it's just really obvious that we should. So when I say most of the time, I'm saying, you know, if it's easy to do the simplification, then do it. But most of the time we just use the quotient rule and we only simplify if we have to.